Hi, and welcome to the Android Video Series presentation on property-based animation. We've already talked about view animation, and the limitations of view animation are that once we animate something, it snaps back to its original position because we're really not affecting the underlying properties of the control that we're animating. So this time we're going to look at property-based animation, and as the name tells us, we are animating properties, not just a picture of the object. So in this layout, I've got a text view and a button, and the text view is a hello world string, and the button is just a normal, regular old button. The on-click attribute here we can see is animate, so I must have a method called animate, and then the text is from a string file, and that text we can see is animate. And both of these are centered. So this is exactly like the layout XML for the main activity in the view-based animation. I haven't changed a thing. Now, in our main activity, however, animate looks very different. First of all, I do grab the text view in the same way. I get find view by ID with the ID of the text view 1. But then I use an object animator. An object animator, as we learned in the discussion, is a subclass of value animator that wraps up all the difficult stuff and allows us to animate properties of any object at all. In order for us to animate a property, that property must have a set, whatever property name, method defined. In this case, we're animating the rotation property of this text view, and we're going to animate it from a starting point of 0 degrees to an ending point of 180 degrees. And I put these F's here to make sure that these are floating point values. Now, if we look at SetRotation, we can see that a view, which is a superclass of text view, has a SetRotation method. And that's good, because it must have. When we used object animator, the property that we are animating must have a set. And if we are going to need to get the value, it must have a get. So here is SetRotation, and we can see that it expects a floating point value and returns a void. So that's why I'm making sure that these are floating point values. Then I set the duration on this text view animation to ½ a second, and then I just go ahead and start the animation. Now, with object animation, we can get very complex, and the same sort of complexity with timing values and everything else, but I wanted to keep it simple here. The point of object animator and property animation in general is that when I run this and click on the animate button, the text view will remain rotated at the end of the animation, because I'm not just changing the view or the picture of the view, I am actually changing the rotation property of the object. So let's go ahead and run it and see what it looks like. In a moment, the emulator will come up with the application. There we go. So I have my hello world here, and I have my animate button here, and now when I click animate, if I had done this with a rotate tag in view-based animation, when I clicked animate, this would rotate through 180 degrees and then snap back to here. But when I click animate, it will rotate through 180 degrees and stay put. So this is the essential difference between property-based and view-based animation. Now, when we're doing something as simple as this, excuse me, when we're doing something as simple as this, property animation is actually quite a bit simpler than view-based animation, right? In view-based animation, to do the same thing, I would have had to set up an XML file and then load it in the layout and then run the animation. With property-based animation, all I have to do is set up an object animator, tell it what property I want to animate, the starting and ending values, set a duration on it, and then start it. This is true. In this case, in very simple cases of animation, property-based animation is much simpler and much easier to implement. However, as your animations get longer and more complex, and we're dealing with alpha channel values while we're doing rotations and we're doing moving things around the screen and more than one animation is happening, then the property-based approach becomes more and more lengthy in our code, and the view-based approach starts to look better and better. The lesson here is that when we can get away with using view-based animation, we should. In other words, if we are animating something and returning it to its original position at the end of the animation, we should use view-based animation. But if we need to retain the underlying properties of the classes, if we're moving things around and want them to stay put at the end, it's much easier to do this kind of animation with property animation rather than view-based animation. All right. We can see that both methods are very, very simple. Depending on your need, depending on the API that you're using, choose one over the other, and we hope that this discussion on view and property-based animation will help you make that choice. Thank you very much.